Hello everyone, I am Rushiv Chandarana. We recently entered into a new year 2020. Before 105 years, Sir William Paul said mathematics is not about equation and algorithm, it is about understanding. So today I would like to present some glimpse about a topic of mathematics, that is probability. People generally gets confused between luck and randomness. Luck is something whose probability cannot be obtained and randomness is something whose probability is obtained. So probability is the study of randomness and uncertainty. So here we go with a topic. Probability is the study of randomness and uncertainty. In other words, probability is predicting the likelihood of future events considering the analysis of past events. So probability is something which deals with randomness and uncertainty. Introduction to the theory of probability. There are two types of signals classified on the basis of theory of probability: deterministic signal and random signal. The nature and amplitude of this signal can be predicted is known as deterministic signal, and the nature and amplitude of the signal which cannot be predicted is known as random signal. So terminologies of probability. Random experiment. The outcome of any experiment which cannot be predicted precisely is random experiment. Sample space. The set of all possible outcomes of a random experiment is sample space. Casino, weather forecast, and stock market are some places where probability can be used in real life. Basic concepts from set theory. Union. The union of two events A and B is the event consisting of all outcomes that are either in A or in B or in both events. Intersection. The intersection of two events A and B is the event consisting of all outcomes that are in both events. Disjoint. When two events A and B have no outcomes in common, they are said to be mutually exclusive or disjoint events. Null set. The set containing no element is called null event, denoted by phi. Conditional probability. If the probability of event A depends on whether event B has occurred or not, then we denote conditional probability as P of A by B. As it depends on A, the event B depends on A, so it is written as A by B. So probability of A by B is equal to P of A intersection B by P of A. As it depends on the event A, the P of A is the P of A intersection B is divided by P of A. It is also known as dependent event. Bayes rule. In order to derive expression from conditional probability, let us perform an experiment n times. Event A occurs say n1 times out of there is n trials, and event B occurs n2 times out of n1 times A has occurred. So n1 times event A is occurring from n times, and out of that n1 times n2 times event B is occurred. So probability of joint occurrence P of A into B is equal to P of A into P of B by A. Therefore, the conditional probability is given by P of B by A, which means the probability of A is depending on the probability of B. Therefore, it is equal to P of A into B by P of A. Therefore, P of B by A is equal to P of B into P of B by A by P of B. Similarly, P of A by B is equal to P of A into P of A by B by P of A. These two equations are known as Bayes rule. So now we will go upon independent events. If the probability of event A does not depend whether event B has occurred or not, then we can denote independent event as P of A by B. P of A by B is equal to P of A, as event B does not depend on the event A. So P of A by B will be also equal to P of A, and similarly P of B by A will be equal to P of B. This is also known as mutually exclusive events. Bernoulli trials. In Bernoulli trials, if a certain event A occurs, we call it as a success. If P of A is equal to P, then the probability of success is P. If Q is the probability of failure, then Q is equal to 1 minus P. As the probability of failure is Q and probability of success is P, the probability of failure will be equal to 1 minus the probability of success. We shall find probability of k successes in n trials. The outcome of each trial is independent of the outcome of the other trials. It is clear that in n trials, if success occurs in k trials, failure occurs in n minus k trials. Since the outcome of the trials are independent of the probability of this event, it is clearly as p into k into 1 minus p into n minus k. That is, but the event of k success in n trials can occur in many different ways. It is well known from the combinational analysis that are nk ways in which k things can be taken from n things, which is the same as the number of ways achieving k success in n trials. So nck will be equal to n factorial by k factorial into n minus k factorial. This can be proved as follows. Consider as a near end containing n distinguishable balls marked 1, 2 up to n. Suppose we draw k balls from the year end without replacement. The first ball could be any one of the n balls. The second ball could be any one from n minus 1 balls. As we have taken out one of the ball from the all box, so it will be n minus 1 balls left in the box. So and hence so on, we can write an equation like, hence the total number of ways in which balls can be drawn is n. First of all, as we have drawn one ball, total number of balls are n, so there is an n minus 1 means, first of all, when we have taken out a ball, then it will be n minus 1, as similarly n minus 2 up to n minus k plus 1 will be equal to n. This means the probability of k success in n trials is equal to nck p of k raised to 1 minus p raised to n minus k into n factorial by k factorial into n minus k factorial p raised to k 1 minus p raised to n minus k. Thank you.